So in the previous video, we talked about quadratic equations, and I told you that I want to discuss about the method of completing the square. Then we said there are foundations we are going to lay. So here, we talk about equation with irrational roots. Then we ask ourselves what root is. Root is simply the solution to a quadratic equation. For instance, when we handled x plus 2 bracket x minus 4 being equals to 0, we're able to get that the solution to this is x equals to minus 2 or x equals to 4. So this is what we call the root of the equation. So this is what we mean by the root. So the root is simply the values that you will substitute here to get 0. So that is the solution to that quadratic equation. Then we talked about irrational. What do we mean by irrational? First of all, we ask ourselves what irrational number is. An irrational number, you remember, is a number the square root does not exist per se. A number that doesn't have a square root. For instance, if you talk about square root of 3, talk about that is the numbers in a short form, or the numbers in square root. Talk about the square root of 2. For instance, I know the square root of 2 is 1.14 something something, okay? So you can talk about numbers like that. Then you can talk about square root of 5. So every number whose square root is not exact, you cannot get the square root explicitly. It's what we call irrational numbers. Another way you can define an irrational number are numbers whose decimal is not recurring. For instance, you have 3.142. This is non-recurring decimal, so it's an example of irrational. Somebody can have maybe 1.412. This is an example of irrational number because the decimals here are not reoccurring. They have non-reoccurring decimals, or simply the numbers in a square root. Square root in the sense that you cannot get their square roots directly. For instance, you know the square root of 4 is 2. But the square root of 3, you cannot say this is square root of 3. So such numbers in this form or in this form is what we call an irrational number. So we want to look at the quadratic equations whose their solution are irrational numbers. And that's what we talk about, the irrational roots. So let's, for example, we have a quadratic equation of this form. We have x plus 3, for instance, raised to power 2 is equals to 5. You agree with me that this is a quadratic equation. Reason is because if you expand this and collect your like terms, you get your quadratic equation. For instance, if I work on this side now, you will see that this is x plus 3 raised to power 2 is the same thing as x plus 3 times x plus 3. If you open up, x times x is x squared, x times 3 is 3x, 3 times x is 3x, 3 times 3 is 9. So this will give you x squared plus 6x plus 9. And that's what you have. So this is a quadratic equation. And you agree with me, it conforms with the general form ax squared plus bx plus c. So your a here is equals to 1. Your b is equals to 6. And your c is equals to 9. So this is actually the quadratic equation. So here now, how do we solve this? You have x plus 3 raised to power 2. So to solve this now, we want to find the value of x, okay? So what do? You take square root of both sides. You take square root of both sides. So why are we taking the square root of both sides? You know that square root cancels index 2. How? You know that if you say square root of x is the same thing as x raised to power half. So we have learned this in indices. So when you now have something, maybe you have y raised to power 2. If you take the square root, you are raising it to power half. So that eventually, these two will cancel 2. So that's why we say the square root cancels the power 2. So that's why if you have anything in index 2 and you want to remove it, especially when it involves equation, then you now take square root of both sides. So this square root will cancel this power 2. Then you now left with x plus 3. So this is equals to square root of 5. Now, what is our x? But you remember what square root is. Remember square root. Square root of 4 is what? Is plus or minus 2. Reason is because there are two things that work. 2 plus 2 times plus 2 will give you 4. Minus 2 times minus 2 will give you 4. So that's why we are saying that the square root is always plus or minus. So that means we're going to put plus or minus. But reason of putting the plus or minus is for you to actually see that two values of x. Because you are dealing with a quadratic equation, you are going to get x equals to something, and that x being another thing. So you have to get two values of x. So that's why we're going to work with plus or minus. Here is a plus or minus. Okay. So now what is our x? So our x now will be equals to, we are making x the subject of the formula now. So when it comes to the other side, it will become minus. So here you still have your plus or minus square root of 5. Now minus 3. So that's what you have. So there are two values of x. Therefore, what will be your value of x? So your x will be equals to, you take the plus part. So plus 5 minus 3. Or you go for the second part, x. That is, I want to split the plus and the minus. So I have minus here. Then the other one becomes minus 5, square root of 5, minus 3. So these are two different values. So this is a value. This one is another value. So what I did is to split my plus and minus. So here I have only one plus. Here I have that minus. So from the plus or minus, I split them into two. Then I got two different values. So what I have gotten is that x now is equals to this or that. So these are the two possible values of x that will satisfy this equation. So to test for it is left as an exercise. So you can put x, you can put the value of x to be this into the equation and see if you get 5. So this is an irrational number because the square root of 5 does not exist. You don't have the square root of 5 per se. So this one is also an irrational number. Because now if I ask you what is the square root of 5, what will you tell me? You won't tell me anything. Then if you place it in the calculator and say square root of 5, it will give you some decimal point that is indeterminate, it's endless. It gives you indefinite decimal points. You cannot really get the exact value. It doesn't have an exact value per se. So that's what we have. So this is an irrational number, this is an irrational number. So this corresponds to irrational roots. So irrational roots now are the solutions of the quadratic equation that is an irrational number.